Yes, can you see the screen?
Yes, sir, we can see.
Okay, you can see. Okay. Yeah. Okay. Yeah. Okay, students. See, actually, the planned one for today was circles and parabola. Okay. So then I realized, like in 1 hour, like instead of finishing half of both things, na, circles I will attach for tomorrow's class, next class, I mean. Okay. Why? Because understanding parabola in detail properly, okay, will help you in understanding ellipse and hyperbola also. Okay, that was the idea of concentrating mainly only on parabola for today. Okay, so let's start the session. So now today's class is on parabola, but in fact, I should remind you that it is the case not only with parabola, even with ellipse and hyperbola, you have the same categories to learn, okay, in a conic. So whenever you are learning a conic, you have like 6 categories to be learned. Very simple. First thing is the geometry of the conic. For example, let's say you are learning circles, then you should know the circle properties. Na? The tangents are drawn from external point, then they are of equal length. There will be some geometry related this thing, property of circle. And every point on the circle is equidistant. Okay. Now for parabola, ellipse and hyperbola also, we have some geometry, standard geometry. Next, you need to learn about focal chord, focal distance and all. Parameterization, tangents, normals, that's all. Properties, okay, not that important in exam point of view. Okay. Okay. So first aspect we'll cover the geometry. Okay. Yeah. Now, the geometry, when I say geometry of ellipse, let me just draw one figure. Yeah. So this is how the standard parabola will look like, right? Yeah. It looks like this. Now, in this, the parabola is symmetric about some line. That line is called axis. Symmetric means you understand, no? Okay. So there is a symmetry of the parabola along one line that is called axis of symmetry or simply called as axis. Okay. So I'm not saying whether it is a x-axis, y-axis. No, just simply axis. That's all. Okay. It can be vertical also, axis of symmetry. Okay. Just the geometry part. And you know that a directrix will be involved. Okay. In parabola. So directrix will always be away from the parabola. Okay. Outside. And the important points here, let me just mark. This is called vertex V. Vertex is the point where the parabola turns. Okay. It's like a turning, no, for the parabola. That is vertex. Whether it is horizontal or vertical. If it is vertical, then this is the vertex. Okay. Yeah. Terminology is important, guys. Next. Focus. Focus. So for every parabola, there is something known as A. Okay. We call it, we keep that notation as A. So which is nothing but from vertex to directrix, the distance whichever is there, that is 2A. Okay. And sorry, that is A, not 2A. Sorry, somehow. Yeah. Okay. And from the same distance from vertex, if you go to the inside of the parabola along the axis, you will get the focus. See, I'm not writing any coordinates or anything. Okay. There is a reason why I'm not writing any coordinates or anything. Okay. You should know the geometry. That means how far one thing is other to other. Okay, is to other. Okay, that is the point of this particular part of the lecture. Okay, next there is something called latus rectum. Okay, latus rectum we call it. Okay, so what is the latus rectum means? It is nothing but a double ordinate passing through focus. Now you may say, sir, what is double ordinate? Double ordinate is nothing but a chord perpendicular to axis. Any chord of the chord means what? Line joining 2 points of on the parabola. So if I join 2 points like this, that is a chord. But how should be the chord? The chord should be perpendicular to the axis. So you can draw many chords which are perpendicular to the axis like this, like many chords. But the chord which is passing through the focus, I mean the double ordinate which passes through the focus. Okay, double ordinate means a chord which is perpendicular to the axis but passing through the focus. That particular thing is called what here? Lattice rectum. This PQ is called lattice rectum. Okay. Now, there is an important property. The most important property of the parabola is what here? You take any point on the parabola. Okay. Let's say PQ is taken already, R. Okay. Then the distance of R from the focus will be same as distance of R from the directrix. That is the property of the parabola, right? SR equals to RM. Keep this in mind. Now, what will be QS? Clearly, we can say that this QS will be, because Q is a point on the parabola, distance of Q from focus is same as distance of Q from the directrix. So how far is Q from directrix? You can see A and A, 2A, na? Because both are parallel. Okay. So which one? Which both are parallel? The orange color line and the blue color line, directrix, both are parallel. So the distance between those two parallel lines is 2A. So distance from Q onto the directrix is also 2A. Since this is 2A, we can say that SQ is also 2A. So by symmetry, this will also be 2A. So this PQ is the lattice rectum. So length of lattice rectum is given by 4A. Okay. And see here how we are getting into ends of lattice rectum, how we are getting P and Q. You start at S, move perpendicular direction to axis. By distance 2A, you will get both the ends of lattice rectum. See, let me just tell you overall brief. That's all. This is the geometry of the parabola. On this only questions will come, equations, everything we'll learn. Okay. See, what you need to remember is, see, there will be vertex. Vertex is the most important point in ellipse. Okay. Now, if this is the vertex will be on axis. Okay. Vertex is the point on axis. No? Okay. Where the parabola turns. Now, vertex, if you go A units right side from vertex, what do we get? Right side or left side, we don't know. Okay, how? It only depends on how the parabola is shaped. For example, if the parabola is like this, then if you go right side, now away from the parabola, you will get the directrix, correct? Like this perpendicular line. If you go inside the parabola A units, then you will get the focus. Then if you go down by 2A units, up by 2A units, then you will get ends of lattice rectum. Okay. That's all. That is the main thing. Okay. Now, let us see the equations, standard equations, okay, of the parabola and all these things. Now, actually, we can write in two ways. Okay. Understanding both is important. Way number one. If it is opening right, then if the parabola is opening right, the standard equation is y square equals to 4ax. Okay, where the vertex is 0, 0. Now, if the vertex is something else, alpha comma beta, then the equation will be y minus beta whole square is equals to 4a into x minus alpha. Okay. Now, what is a? A already we have talked about now. That is length of lattice rectum is only 4a. Okay. So a is nothing but distance between vertex and focus. Okay. For every parabola, the distance will change the shape. Okay. So that is what we are going to. Okay. Now, if it is opening left side, very simple. If it is origin, then it is y square equals to minus 4ax. If the vertex is not origin, if the vertex is alpha beta, then again replace y by y minus beta whole square equals to minus 4a into x minus alpha. That's all. The same way, if it is opening upwards and this is origin, vertex is origin, then it is x square equals to 4ay. If it is opening downwards and this is alpha, sorry, opening upwards only, but now if the vertex is alpha beta, then it will be x minus alpha whole square equals to 4a into y minus beta. You see, in everywhere, if the vertex is alpha beta, we are replacing x by x minus alpha, y minus y minus y by y minus beta. Okay, that is what you need to do. And same way, if it is opening downwards, origin is the vertex, then it will be x square equals to minus 4ay. If it is opening downwards, if the vertex is alpha beta, then the equation will be x minus alpha whole square equals to minus 4a into y minus beta. Okay. Now keep this in mind. We'll see some questions based on this concept first. Okay. Yeah. 1 second. Let us see this question. Now, the form which we have seen just now, it is helpful whenever the parabola equation is not given, but you need to find the equation. Okay. Because you can see whatever form we have seen in that, to find the parabola equation, you just need how many things here? You just need to know, I think, 3 things. What are those 3 things? How the parabola is opening, right, left, up, or down. That is one information which you should know. Second information, what is the vertex? And third information which you should know is what is the value of A for this parabola. If you know these 3 things, then you can write the equation of the parabola like above. Okay. If you know those 3, keep that in mind, guys. Okay. Now, let us see this one. Now, if the extremities of lattice rectum of the parabola are 3, 2 and 3, minus 6, then find the possible equations of the parabola. Okay. So in this question, what they have given is, okay. The one thing which you should be careful is, when you are marking these points, don't just mark like this, 3, 2 and 3, minus 6. This doesn't make sense. Why? Because both are having same x coordinate. No? Okay. So don't mark like that, because that will have an effect on shape of the parabola. I will tell you how. Okay, you see, extremities are 3, 2. So if 3, 2 is somewhere here, 3, minus 6. These are extremities of lattice rectum. Okay, and we know that if you remember the geometry, the midpoint of these two is only the focus. No? Okay, so what is the focus of this parabola? 3, 2 minus 6 by 2 minus 2. That is the focus. Okay. Now, what is this length? This length is 4. So, distance between focus and one end of lattice rectum is what? 2a. 2a is 4. So, a for this is how much here? 2. So, we got the a. Next, from focus, now depends on the shape. Okay. So, if these two are the ends of lattice rectum, then the parabola can be like this. Yes, sir? Or the parabola can be like this. Let us write the equations in both the cases. Let us write for blue one. Okay. For blue one, how to find the vertex? Because for both the parabola, this line, whatever I am drawing just now, that will be the axis. Okay. So coming to the blue one, now this is 2a, then this will be a, na? We have seen that already. Distance between vertex and focus is a. A is 2. So to get the vertex of the blue color parabola, we need to go left side by 2 units. So from 3 comma minus 2, if you go left side by 2 units, you will get 1 comma minus 2. That's how you write the points. No? Now you know the vertex. You know the A. You know how the parabola is opening. It is opening to the right side. What will be the equation? Y minus of minus 2 whole square. Y square equals to 4x type it will be now. Okay. Equals to 4 into A, that is 2. Instead of x, you have to write x minus 1. So y plus 2 whole square equals to 8 times x minus 1. Okay. So that is the one possible equation. And if you talk about the green one, then from focus, if you go right side by A units, what is A? 2. By 2 units, if you go 5 comma minus 2, that will be the vertex of the green color parabola. It is opening left side. So the equation will be of the form y square equals to minus 4ax type. Okay. But you know the vertex, it is 5 comma minus 2. So the equation will be y minus of minus 2 whole square equals to 4 times minus 4ax. Correct? So minus 4 into a is 2. Instead of x, again, you will write x minus alpha. So finally, the equation will be y plus 2 whole square equals to minus 8 times x minus 5. Okay. So these are the two possible equations. Now you will realize why I was stressing to mark these 2 points like properly, little properly, whether vertically or horizontally. Because, for example, if you have gone ahead and marked these 2 points like this, then the parabola you will see will be upwards and downwards. No? But actually, what is the parabola? It is left and right. Okay. So that will change the entire equation of the parabola. Fine. Let me just see. Any doubts are there? Anyone? Got it. Yeah. Next. The ends of lattice rectum whose focus are okay. This is very easy. They have given the focus, they have given the vertex. They are asking the ends of lattice rectum. Okay. How to do? Think. It looks easy, but yeah, not that easy. Okay. It is okay. Think. Ends of lattice rectum of the parabola. Focus is given. So I am randomly drawing the figure. Okay. Actually, the parabola is not horizontal. Okay. Let me draw it like this. This is the axis. So they have given the focus and they have given the vertex. Vertex is 2 comma 7. Focus is minus 1 comma 2. You can see that for both the coordinates, x is not same, y is not common. That's why I have drawn in inclined way. Okay. Now what you need to find? Ends of lattice rectum. No? P and Q. Okay. So here it is like this. See, if I take this as a vector, let's say this vector is v bar. Okay. Then this vector length will be 2 times. No? Because if this is A, I have drawn roughly figure, that's why it doesn't look twice. But then already we have seen in the geometry that if that is A, this will be 2A, right? Okay. So if this vector is V bar, okay. So basically what you need to do is you have to rotate that vector by how much angle? 90 degrees. If you rotate it anti-clockwise by 90 degrees, then you will get that vector here. Okay. Let me draw it in red. If you rotate that vector by 90 degrees clockwise, you will get it here. Okay. Now, not only rotate, but you need to double the length. Then you will reach the complete vector will be pointing Q. Okay. Same thing here. Okay. Now, how do you rotate vectors? already I think you should know the technique, that is using complex numbers. Okay, and the 90-degree rotation is very common, you get it in physics also. If you have to rotate 90 degrees anti-clockwise, then multiply by I. If you have to rotate 90 degrees clockwise, then multiply by minus I. Now you may be thinking, sir, is that I same as I cap in vectors? No, it is I in complex numbers. Okay, but you are saying vector then complex number. In complex number also we treat complex number like a vector. Na? For example, let's say if 2 comma 7, this vector whichever is there, how should I draw? Final 2 minus of minus 1, just like in vectors only. X components you subtract. That will be the real component now. That is 3. Y components if you subtract, how much will you get in? 5. That will be the imaginary component, 5i. Okay. Now, what we have to do? If you have to rotate anti-clockwise, multiply that by I. So 3 plus 5i into I, how much it will be? Minus 5 plus 3i. Okay, but by multiplying by I will only give us half the vector, na? From S to Q. We need complete vector, so you have to multiply twice. Because the length is twice, you have to multiply that vector by 2 times. You'll get minus 10 plus 6i. So what is this vector, guys? Minus 10 plus 6i. Now what will be the coordinates of Q? Okay, if you know the starting point, let's say if you have a point, starting point as A bar, or you can say starting is 1 comma 2, and if this vector is 3 plus 4i, then what will be the ending point? To 1 you have to add 3, no? 4, 2 plus 4, 6. Okay, so because the vector means from A to B, if you are going, you need to go 3 units in X direction and 4 units in Y direction. So 3 units X you increase, 4 units Y you increase, you will get that coordinate. Same way, what will be the coordinates of Q? Minus 1 to minus 1, add the X component, minus 11. To 2, you add the Y component, that is 6. You got one end of letter vector. Now one end is enough, other end easily, because midpoint of PQ is S only. Na? So you can find P. Okay. Okay. Is that clear, guys? Just that rotation part I want to explain. Okay, how I got this one. Okay, let me just explain. I think doubts are there in this part. See, very simple. Actually, if you have any 2 points, let's say the 2 points are 1 comma 3 and 5 comma 7. What you do is you join like this. For example, this vector I need. You know how to write vector, right? You will write 4i cap plus 4j cap. Like that you will write now. Same way you write, but now in complex numbers, by subtracting the real x components, you will get the real part of the vector. That is like 4. And by subtracting the y components, that is also 4. So 4i you will write 4 plus 4i. That is that vector. Okay. Like that. Now, this vector, if I want to rotate by some angle, let's say theta, then you need to multiply this vector, that is 4 plus 4i by e power I theta. You know e power I theta, no? Euler's form. Like that you need to multiply. Okay. That's all. That is what I was saying. Since it is 90 degrees, it is easy. So you have any vector v. If you have to rotate by 90 degrees, you have to rotate by e power I. 90 is what? Pi by 2, na? Theta means. E power I pi by 2 is I only, right? Like that. Okay. Next. Yeah. So that is one part of the geometry. That is writing the equation. Next is if equation is given, now you need to figure out how to draw the figure. That is also important only, guys. Okay. From the equation, how to find vertex and all these things. Okay, very simple. Actually, the equation can be 2 ways, parabola. Either it will be, see if it is given in standard form, that is y square equals to 8 times x minus 3, then it is easy. You can go ahead and see that, okay, if it is of this form, then it will be opening upwards. Okay. And we know the form y minus beta whole square equals to 4a into x minus alpha. So alpha is 3, beta is 0. So vertex is 3 comma 0. Sorry, y square equals to 4x opening right side, no? Yeah. So yeah, like this. Okay. So then it will be right side opening. So if it is given as a perfect square, it is easy to do. Okay. But not every time you will get as a perfect square. The parabola equation will be two ways, guys. It can be categorized. One is of the form ax square plus bx plus c. Other one is x is equals to ay square plus by plus c. Okay. Either the parabola equation can be quadratic in x or it can be quadratic in y. If it is in quadratic in x, already you know, it will be opening upwards if a is positive. It will be opening downwards if a is negative. And the important point is the vertex. The vertex will be x coordinate will be minus b by 2a. And what will be the y coordinate? Just substitute that x coordinate, you will get the y coordinate. Okay. Because every point on this parabola will satisfy this equation. That's the funda. Same thing here. X coordinate of the vertex will be minus b by 2a. Y coordinate will be y of minus b by 2a. Okay. Next, when it comes to equation of this form, it will be opening right side if a is positive. Same exactly like opening up and down only. If a positive, opening upwards, na? Here opening right side. When a is negative, opening left side. And here also almost the same thing, but only difference is the vertex y coordinate will be minus b by 2. And x coordinate will be, you have to substitute in that expression. What is x? Ay square plus by plus c. No? Substitute in that, you will get the x coordinate of the vertex. Y coordinate is minus b by 2a. X coordinate is x of minus b by 2. You have to substitute that y coordinate. Okay, that's all. Now, on this, we'll see one or two questions. Then we'll proceed to tangents. Now, you see this one. First question. The coordinates of the vertex of the parabola, this parabola, are minus 3 comma 1. Simple. What will be the coordinate? If the parabola is given like this, that is, it is either opening a is positive, so it is opening right side. No? So what will be the coordinates of the vertex? Y coordinate is minus b by 2a. Correct? That is what formula we have seen. That is minus p by 2 times 2, which is minus p by 4. Okay. So minus p by 4. But they have given that minus p by 4 is how much here? 1. Y coordinate of the vertex is 1. No? So which means p is minus 4. So now I can write the equation as 2y square minus 4y plus q. Okay, fine. So the y coordinate of the vertex is 1. And what is the x coordinate of the vertex? Minus 3. That means if you every vertex is a point on the parabola, it should satisfy this equation. No? So minus 3 comma 1 should satisfy this equation. So x is minus 3 when y is 1. So 2 minus 4 plus q, you will get the value of q. Okay, q is how much here? You will get it as minus 1. P is minus 4. Okay. Next. Like this, some equation is given. Find the vertex, focus, directrix, length of a lattice rectum, everything. That is okay, simple only. I think you can do it for okay homework. That also you can do it. There is one tough question. That's why, yeah, this one. After this, we'll go for tangents. Okay. If the line is the directrix of the parabola, then one of the values of k is. Now they are saying this is the directrix of this parabola. Okay. Now, what is the parabola? That is kx equals to, or you can write it as y square equals to. Let me write it like this only. Kx equals to y square plus 8. Okay. Now they are saying this is the directrix, x equals to 1. So let me draw like this. X equals to 1 is the directrix there. Okay. Now, can you tell me it is opening right side or left side, or how it will be? It can, if K is positive, then it is opening right side. If K is negative, it is opening left side. Okay, we'll take both the cases. If K is positive, okay, then it is opening right side because it is x equals to 1 by k times y square plus 8 by k, like this, no? It is like ay square plus by plus c. 1 by k is positive, so like that. Okay. Now, what will be the vertex? Minus b by 2a, minus 0. There is no y coefficient. Okay. So we can say that the vertex y coordinate is 0. And if you put y0, x you will get it as 8 by k. Okay. Don't forget, I have assumed k as positive. Okay. And the parabola is opening right side. Okay. So you can't have the parabola intersecting the directrix. No? That's why I've drawn to this side. This is one possibility. And other possibility on the left side, like this, opening left side. Okay. That time k must be negative. So when k is positive, the diagram we are assuming like this. When k is negative, then again, y coordinate will be 0. Because the formula is same, whether it is opening upwards or downwards, where we have seen. Yeah. You see, the formula is same, minus b by 2a. Upwards or downwards, the vertex, if you want to find. Okay. So 0, and this will be 8 by k. Now that's all. Now, what is that you need to find? You need to find the value of k, and they are saying this is the directrix. Okay. Okay. Now, we discussed the value of a for a parabola. No? Now, if I ask you for this equation, if I give you this equation, if I ask you what is the value of a, what is the value of a, then what will be the answer? Okay. The a means a for the parabola. 4a y square equals to 4ax is there, no? That a I'm talking about. Okay. Simple. Whenever equation is given like this, the length of lattice rectum, okay, 4a, length of lattice rectum is 1 by coefficient of x square. In this case, the value of 4a is 1 by coefficient of y square. This is just a direct formula to write. What do I mean is, for example, if I have y square equals to 8x. Here 4a is direct, it is 8 only. Okay. Now, if the equation is 2y square plus 3y plus 9 plus x is equal to 0, this is a parabola equation. Now, for this parabola, what is the value of a if I ask you? Just write x in terms of y, minus 2y square minus 3y minus 9. What is the coefficient of y square? Minus 2. So your 4a will be simply 1 by modulus of coefficient of y square, that is minus 2. So your a will be 1 by 8. Like that. Okay. Fine. Now, where were we? Yeah. So for this parabola, I have written x in terms of y, or like this. So what will be the value of 4a? 4a will be 1 by modulus of coefficient of y square, mod 1 by k. So your 4a will be nothing but mod k. Already they have told. So a will be how much here? Mod k by 4. Yeah. Now if k is positive, a will be k by 4. So this distance will be k by 4. This is previous IIT question. You see how complicated the question can. Okay. And if k is negative, then mod k will be minus k. Then that time we'll say this is minus k by 4. Now this point is 1 comma 0. Now the distance will be what? 8 by k minus 1. You equate it to k by 4. Solve it, you will get the value of k. Okay. Same way here. 1 minus of 8 by k is equals to minus k by 4. Solve it, you will get the value of k. Okay. Yeah. Next, we'll go to the tangents. Okay. Before tangents, first we need to see parametrization. Okay. Very important in parabola. if it is y square equals to 4ax parabola, that is opening right side, general point what we will take here, it is 8a square comma 280. If it is opening left side, y square equals to minus 4ax, then general point will be minus 80 square comma 280. If it is opening upwards, x square equals to 4ay, 280 comma 80 square. If it is opening downwards, x square equals, these things will be, you'll find in textbook, you need to, okay, 280 comma minus 80 square. You need to remember them, okay. This is something which you need to again go through the textbook. Sorry. I'll tell some more things which you need to prepare, okay, from the textbook. I'll get into the, okay. So you need to go ahead and see in the textbook what is the general form of tangent. In slope form and also in parametric form for all four cases. And even tangent and normal, I will say. But tangent is very important, okay. There will be a set of 4 equations. In slope form, there will be 4 equations. In parametric form, there will be 4 equations. You need to remember them, okay. Now I'm not deriving and all those things, because I want to just explain you where you have to use what, okay. Because when it comes to tangents to the parabola, there are actually 3 forms. One is the point form, other one is slope form, and third one is parametric form. Understand this very carefully. Now, first step is you have to go ahead and remember all those slope forms and parametric forms. Okay. Now, when it comes to application, where we will use them. Okay. Point form, what we till now we didn't see what is point form. Point form is very straightforward. Okay. You would have seen something like S1 equal to 0, or in some books it will T equal to 0. Okay. If not, then you have to know that by this time S1 equal to 0 or T equal to 0. That is a common notation. Okay. You guys know that one already? But you have to go ahead and learn this one, because these are time taking ones. If it is a regular class, I would have explained, but in revision, I have to just, because that's not a big task. You can understand it yourself by watching one YouTube video. Okay. So you will get a equal, for example, let's take a parabola. Its equation is y square equals to 4x. Okay. I will take a point on this parabola. 1, 2 is the point on this parabola. Now, if you want the equation of tangent in this point form, if you know a point on the curve, that is the curve is y square equals to 4x. If you know the point on it, then the equation of the tangent will be on at that point, the equation of tangent is simply t equal to 0. That means your y square, you will write it as y1, and here x is there, x you will write it as x plus x1 by 2. Now in this case, what is y1, 1, 2? This point you will use. So y into 2 is equals to 4 times x plus 1 by 2. So you will get 2y is equals to 2 times x plus 1. You will get y is equals to x plus 1. So if you know how to write t equal to 0, then if a point on parabola is given, then the equation of tangent can be written directly. We say it as writing t equal to 0 for this one with respect to that point. Okay. Now the same will apply for ellipse or hyperbola or circle. Even on the circle, if there is a point which is given, you need to find the tangent equation. The answer will be t equal to 0. Okay. Even in case of ellipse also, if there is a point on the ellipse which is given, and if you want the tangent on that at that point, the equation will be t equal to 0, like that. Okay. So that is the point form. So when do you use the point form of tangent? Simple. If the point on the curve is given and you need the equation of the tangent, then you use the point form. Now slope form. When do we use the slope form? I will give one example. Like if I take y square equals to 4x, the slope form of tangent is given by y is equals to mx plus a by m. This is called general equation of tangent. To y square equals to 4x in slope form. Like that for other things also you need to remember. Okay. Okay. What does this mean? It means no matter what is the value, for example, if I take y square equals to 8x, the value of a is 2. So y is equals to mx plus 2 by m. This is the general equation of tangent. 2y square equals to 8x. That means instead of what values of m can you put? Instead of m, you put anything. Let's say 10 if I put. Y is equals to 10x plus 2 by 10. Y is equals to 10x plus 1 by 5. What is this? This will be a tangent to y square equals to 8x. Okay. And what is the slope of the tangent? 10. Okay. So anyway, so this is no matter what value of m you substitute other than 0, this line is going to be tangent for y square equals to 8x at some point. Okay, fine. Now that is the meaning. Okay, now where do we use it? Simple. Where do we use slope form means in two cases. First thing is if slope is given or information about slope is given. Okay, then you use it. That is first one. We'll see the questions, then you will understand. Second one, very important, tangents from external point. This is the main purpose for using the slope form. How, sir, means? Let us take one example, like y square equals to 4x will take. Okay. Then what will be the, now for this parabola, I will take an external point. Let's say it is minus 3 comma 2. Okay. Now just by the common sense only. Okay. Just if you look at the figure, one second, let me draw the parabola again. Yeah. Just if you see the figure only, I think we can say that there will be two tangents from that can be drawn onto this parabola from minus 3 comma 2. Okay. Now if I ask you what will be the slopes of these two tangents. Okay. Now it became a question of finding the tangent from an external point. No? What you do is simple. Write the slope form of this one. What did I ask the question? What are the slopes of these two tangents? Okay. That is a question which I have asked. What you do is write the slope form of this tangent to y square equals to 4x. What is that slope form? Y equals to mx plus 1 by m. No? A is 1. No? Then substitute this point minus 3 comma 2 in this line equation. That is y is 2, x is minus 3, minus 3m plus 1 by m. Now simplify. You will get 2m is equals to minus 3m square plus 1. You will get 3m square plus 2m minus 1 equal to 0. Are we getting a quadratic equation here? Now the roots of this quadratic equation are only m1 and m2. That's all. Okay. Like 3m square plus 3m minus m minus 1 equal to 0. So 3m into m plus 1 minus of m plus 1 equal to 0. You'll get m is equals to 1 by 3 or minus 1. So one tangent slope is 1 by 3. One tangent slope is minus 1. Like that. Okay. So that is the main use of what here slow form. Okay. Next. So sometimes what they do is they'll give some uh, tough point. This one, instead of -3 to some other point it may be. Let's say they ask what is the angle between the tangents drawn from that point onto the parabola. Okay. Then what is the angle between the lines here whose slopes are m1 and m2? Tan theta can be written as mod of m1 minus m2 divided by 1 plus m1 m2. Correct? This is the formula. No? And already we know that m1 m2 are the roots of whatever quadratic we get. Okay. Now in this case the quadratic is very easily factorable, but that need not be the case every time. No? Okay. So in that case you need not find m1 and m2. What is required to find the angle between the lines? You need difference between the roots and product of the roots. Okay. From in quadratic, sum of the roots, product of the roots, difference between the roots, direct formulas are there. Na? Apply them, you'll get the answer. Okay, fine. Next, we have third one, parametric form. Now you may be wondering, sir, then what is parametric form? One second. Let me just see any doubts or anything is there. Oh, yeah. Now you may be wondering, sir, then third one you told, na, parametric form. What is the use of parametric form? Okay. Yeah, this one. Simple. Parametric form is used in locus questions, and also let us see what happens. I told general equations will be there in both slope form and parametric form. Na? Now in slope form, if you substitute an external point, what you will get? You will get the slopes of the tangents from that point. Okay. If our y square equals to 4x, what is the parametric form? Y is equals to, sorry, ty is equals to x plus t square. Yeah, again, how did I write this equation? I told you, na, just to refer any book, you will have these standard forms for in both slope as well as parametric form for all the four cases. Okay, you need to remember them. Now, this is the parametric form of tangent for this y square equals to 4x. Okay. Now, same question from -3, 2, you are drawing the tangents. So now if I substitute -3, 2 in parametric form of tangent, what will I get? Okay, let us just substitute and see. 2t equals to -3 plus t square. You are getting like t square minus 2t minus 3 equal to 0. So which is t minus 3 into t plus 1 equal to 0. So t equals to -1, 3. Achha, you are getting some t values. What are these t? These are nothing but t values for. So that means at this equation, you are getting two roots. Let's say the roots are t1 and t2. So here t1 is -1, t2 is 3. Okay. But in general, I am saying the roots will be t1, t2, let's say. And this t1, t2 are nothing but parameters, parametric values, or you can say, or parameters, you can say, for the points where these tangents are touching the parabola. Okay. Because from parametric form, you will learn that every point on the parabola will have some parameter, no? 1, 2, 3, whatever it may be. Okay. Now, if you substitute this point in the parametric form of tangent, you will get these parameters, touching points. Okay. Oh, let us see one or two questions. Yeah. That is about focal chord. Let us see. Yeah. You see this question. Angle between tangents from 1, 4 onto this parabola. Now, can't you find? You just need to write y is equals to mx plus a by m, that standard equation for that parabola of tangent in slope form. Substitute 1, 4. 4 is equals to m plus 1 by m. You'll get m square plus 4m, not plus 4m, minus 4m. I'm bringing left side, plus 1 equal to 0. Now, what are the roots of this equation? The slopes m1, m2. Okay, of the tangents. Now they are asking the angle between the tangents. So tan theta is equals to modulus of m1 minus m2 divided by 1 plus m1 m2. So for a quadratic, difference between the roots alpha minus beta is square root of discriminant by mod a. So here discriminant is how much? B square minus 4ac. So 16 minus 4 divided by mod a is 1. So root 12, which is 2 root 3. That is difference between the roots. 2 root 3. 1 plus product of the roots. Product of the roots is 1 only. So tan theta is root 3. Then what will be theta? It is pi by 3. Angle between the tangents. Okay. Yeah. So whatever is related, yeah. Next one is chord of contact. You see, there is something called chord of contact here used in this question. Huh? Okay. So it is continuation of this concept only. That is what here. If you have a parabola from an external point, just now we have seen that two tangents can be drawn. No? Like this. These are points of contact, Q and R. Now, a line like this chord passing through these points of contact, that is called chord of contact. Okay. Now, how do you write the equation of chord of contact? Same, T equal to 0. Okay. Because, okay, you may say, sir, this looks familiar, T equal to 0. Where did we use this T equal to 0 previously? If you have a parabola, if I give you a point on the parabola, and if I want the equation of tangent at that point, it is also T equal to 0. And if the point is outside, and if I do T equal to 0, what will I? If the point is on the parabola, if I do T equal to 0, I will get the tangent. If the point is outside and do T, and if you do T equal to 0, you will get the chord of contact. Okay. Yeah, there is another thing. If it is inside, I will not go into it. Okay. But just keep these two in mind. Okay. Now coming to this question. From the point 4, 6. So this point is 4, 6. Pair of tangent lines are drawn to this parabola. Y square equals to 8x. Okay. Okay. Two tangents we can see also. The area of the triangle formed by this pair of lines and the chord of contact. That means area of triangle PQR they are asking. Okay. Now, think about what all you can find. Can you find the equation of the red line? Yes, we can find. But just by finding how we can find the equation of the red line? T equal to 0. But just by finding the red line equation, that means we know the point 4, 6. We know the base equation. We won't get the area of the triangle. Maybe we will get the height of the triangle. But we should know the length. Na? Base means RQ length we need. Okay. So that will not work. What we will do is, if I know the coordinates of Q and R, then that means for this triangle, all the three coordinates I have, then I can find the area. No? Now, already we have seen a technique how to find the points of contact. How? If you want the slopes of the tangents, use the slope form. If you want the points of contact, use the parametric form of tangent. Okay. So what is the parametric form of tangent for this? Ty is equals to x plus 8t square. Actually, equation is 2t square. I will write 4, 6 substitute. 6t is equals to 4 plus 2t square. You will get it as t square minus I divide by 2. 3t plus 2 equal to 0. You will get t minus 1 into t minus 2 equal to 0. So t is equals to 1, 2. So one point will have t as 1. Let's say q has t as 1. And t is 1, not x coordinate. Okay. Because what is the parametric points for y square equals to 8x? 8t square, 2at. That is 2t square, 2a, 4t. Now, if you put t1, what do you get? 2, 4. So one point is 2, 4. Then what will be the other point? If you put t equals to 2, you will get 2 into 4, 8, 8. You know all the three coordinates, no? The area you can write directly. Okay. The det method. x1, y1, 1, x2, y2, 2, 1, like that. Okay. Next. Yeah, many questions are there on that concept. Now, one important property which is there in parabola. See, actually, if you see all the parabola previous JEE mains question, na, the main knowledge which you should have for solving those questions is, if you see that questions, 50% of them are based on geometry. That means they will give the equation. They will ask you in the option, what is the vertex, what is the focus, what is the end of lattice rectum. Okay, or vice versa, reverse also. They will give these points and they will ask the equation. Okay, and second part will be tangents. So tangents means very basic. You should be able to write the equation of tangent properly. That's all. Okay, that is the main motto. Okay, yeah. Next one, there are so many properties, but again, on properties questions are not coming. Okay, and it won't also. It is not correct. It is just memory based. But one property of parabola is very important. Okay, what does that mean? Yeah, this is parabola. It's actually totally linked property. So that's why I'm discussing mainly. Yeah. But normally I don't tell students to remember any properties. Okay. Yeah. So you know that this will be focus, and any chord which is passing through the focus, any chord which is passing through the focus, it is called focal chord. Okay. So this is a focal chord now. Okay. So PQ. Now, if P is parameter of P is T1, 81 square, comma 281. Q is 82 square. If the parameter is T2, then its coordinate will be 82 square, comma 282. Okay. Yeah. Now, at P and Q, if you draw the tangents, no? One tangent and okay, yeah. Let's say they are meeting at R. Then first thing you need to remember is the coordinates of R will be A T1 T2, comma A times T1 plus T2. Very easy to remember. No? The x coordinate will be nothing but like a geometric mean, A T1 T2. That means multiply these two x coordinates, and if you take the square root, na, what do we get? You will get that only. Na? You can remember it easily that way. And the y coordinate of the point of intersection of tangents will be simply average of these two. Okay, that much you can remember. Na? Okay, now this is for in general any anything. Now focal chord, what will be the properties will be, if this parameter is T2 and this parameter is T1, then T1 T2 will be -1. If that is the thing, then you can see clearly for the point R will be minus A comma A times T1 plus T2, because T1 T2 is -1. So x coordinate of R will be always minus A. That means R will be on the directrix. That is first important point. Okay. That is tangents drawn. Let me write it here. Tangents drawn at the ends of focal chord intersect on directrix, and also the angle between them will be 90 degrees. That also you have to keep in mind. Okay. Yeah. Again, derivation we are not seeing. I'm just writing the property. Okay. So vice versa, reverse also. You take any point on the directrix, you draw tangents, then what happens? You will get two tangents, and this, if you join those two, that will pass through focus. Okay. And also the angle between the tangents will be 90 degrees. Okay. Just based on this property only, maximum questions are coming. There are Again, complicated properties unnecessary. Okay, at this point of time to learn. Okay, fine. Yeah. Okay. Okay, guys. So that is the thing. Yeah, you may say, sir, normals we didn't discuss. Yeah, normals there is not required because see, in tangents, whatever we have discussed. Okay, from external point, how will you find the tangents? Slopes of tangents. You will substitute the point in which form? Slope form of tangent. Correct. And if you want the points of contact, what will you do? You will substitute that point in the parametric form of tangent. Correct. Same way, in case of parabola, if you're talking about normal, again you need to remember like okay, when it comes to normal, only two equations you can remember. Y square for these two, 4ay, 4x, y square equals to minus 4x. Maximum, this is enough. In mains, they are not going beyond that for normal when it comes to normal. Okay. Slope form equation will be y equals to mx minus 2am minus am cube. Okay. Parametric form will be y is equals to minus tx plus 280 plus 80 cube. Okay. Now again, from any point, let's say if I have a point, let's take a random point. I will take y square equals to 4x as the curve. Then the slope form equation will be mx minus 2m minus m cube. Okay. Now I'll take a random point. Let's take it as 3 comma 1. Okay. Now, if I substitute this point in this, what will I get? 1 is equals to 3m minus 2m minus m cube. If I take everything one side, m cube minus m plus 1 equal to 0. Are you getting a cubic equation or not? The roots of the cubic equation are nothing but the slopes of the normals which are drawn from that point. Okay. Whatever normals we are drawing from 3 comma 1, the slopes of those normals you will get. Okay. But you may say, sir, cubic equation doesn't mean 3 real roots. Na? There can be 1 real root also. Yes, that is the task. Okay. So that means how many normals can be drawn from a particular point means you will substitute that point in the slope form of normal. You will get a cubic equation. Then you have to analyze whether that cubic equation has 3 roots or 1 root or 2 roots. I mean, like 2 roots are means 2 equal and 1 distinct like that. Okay. So the basic the way in which what you are doing, it is exactly the same. If you substitute the point in the slope form, you will get the slopes. Now, what slope will I get, sir? Means if you substitute in the slope form of tangent, you will get the slopes of tangents from that point to the parabola. If you substitute that point in the slope form of normal, then you will get the slopes of normal from that point. Okay. Now, 3 comma 1, if I substitute in the parametric form, okay, what is the parametric form for y square equals to 4x? Parametric form of normal, y is equals to minus a is 1 na? Plus 2t plus t cube. Now if I substitute 3 comma 1, 1 is equals to minus 3t plus 2t plus t cube. You will get t cube minus t minus 1 equal to 0. Now again you are getting a cubic equation. Now this cubic equation will have 3 roots t1, t2, t3. Now what will be the roots of this cubic equation? The roots are nothing but the parameters of these 3 points. There it was point of contact. Na? Here it will be foot of normal. Okay, that's it. That much in depth up to slope, yeah, you do. Because I'm just saying best utilization of the time. Okay, you can do many things. You can prepare only for parabola for 1 month also. Okay, but whatever is required for the exam, that we have to see. No? Okay. Okay, so mainly concentrate on geometry and tangents. Similar thing, if somehow if normal question also comes, yeah, the procedure is similar with respect to tangent and normal. Okay, fine. Okay, guys. So we will stop the class here for today.